So for 1415, we are solving absolute value equations and inequalities. So last class we graphed absolute value inequalities, not inequalities, equations. Now we're going to solve them algebraically, okay? So remember, absolute value is just the distance a number is from 0 on a number line. So absolute value is always going to be positive, okay? For it to be an absolute value equation, it's just an equation with absolute value, okay? With absolute value, though, you have what could be extraneous solutions. And what that means is you solve it, you get all the way down to x equals 5. Let's say it's x equals 5. But when you plug it back in, it's not actually true. Okay, so it's an apparent solution that's not actually true. So that's when you have an extraneous solution. So we are going to check every single problem that we do. Okay? Now, if you think back to when we did our parent function table for absolute values last class, okay, we would have our x values that were -2, -1, 0, 1, 2, and then we would get the absolute value of that to get our y value. So if I did the absolute value of -2, what would that give me? 2. If I took the absolute value of +2, what would that give me? 2. So because both of these give me a +2, when I'm solving absolute value equations, I'm going to have to consider what if it would have been negative. Because when I take the absolute value of that, no matter what, I get a positive. Okay, that's like if I say, what did I take the absolute value of to get a 5? Well, what were my two options? The absolute value of what would give me 5? I could do the absolute value of -5 to get 5, and I can do the absolute value of +5 to get 5. Okay, so because of that concept with absolute value always spitting out a positive, we're going to have to consider both the positive solution and we're going to make a second equation with it being negative. Okay, so every problem we have, we're going to have two equations. It's not going to be that hard. Okay, as long as you remember one's going to be positive, one's going to be negative, you work it out and then you check it. Okay, now if you have something where you have the absolute value of x plus 3 equals -5. Okay, well, what did I just say about absolute value? It's always what? Positive. So absolute value is always positive, but here I'm saying it's equal to a negative number. Is that true? No, a positive can never be equal to a negative. So when you have an absolute value equation equal to a negative, there's no work to be done. It's just automatically no solution. Okay, so you're going to have to think about positive and negative numbers here, not just let me work it out and just memorize the steps. Okay, you have to think. So to solve it, we want our absolute value bars by themselves. Okay, so we're going to isolate that first. Once we have it by itself, then we're going to drop the bars, and that's when we split the positive and the negative solution. Okay, then we're going to solve both of those, plug it back into our original, check for extraneous. Okay, and I'll show you how to type it in your calculator so you can do it quickly and not by hand. Okay, so our first example, I have the absolute value of x equals 7. Okay, my absolute value bars are by itself. There's nothing in front or subtracted or added behind it. So I can now just split it into my x equals +7 and x equals the -7. Okay, here, once I split it, there's nothing to solve for. Typically there is. Okay, but there's nothing to solve for here, so I'm just going to check it before I box it in. If I take the absolute value of 7, does that give me 7? Yes. If I take the absolute value of -7, does that give me 7? Yes. So they're both good solutions. Okay. Now example 2, I have the absolute value of c equals -1. What do I do there? That should be no solution automatically. I cannot have a positive equal a negative. Okay, so anytime you have equals a negative, you should have something going off in your head that this isn't right, and you have to start thinking about things, okay? Now with number 3, I've got the absolute value of -9 minus y equals 5. Okay, my absolute value bars are isolated. There is an added thing with my y inside, and that's okay. All I'm looking at is on the outside. So it's by itself, so I can split negative 9 minus y equals the positive 5, and negative 9 minus y equals the negative 5. Okay, we always keep the same numbers, just make it negative for that solution. Okay, now we're going to solve. If I want to solve for my y, I want y by itself. What am I getting rid of? I'm going to add 9 to both sides. Negative y is equal to 14. And then what do? I have a negative y. I want a positive y. I'm going to divide by negative 1. So y equals negative 14. Before I box it, though, I'm going to solve the second one, then check them both at the same time. Okay? So then my second equation, I'm going to do the same steps. I'm going to add my 9. And now it's negative y equals positive 4. Negative 5 plus 9 is a 4. Then divide by negative 1. And y equals negative 4. Okay? Do you have questions on how I solved that? All right. So in your calculator, try to do it without a glare. We're going to store these values for x. Even though my problem says y, we're going to store it for x in our calculator, and then we're going to type our original. Okay, so I'm going to take my negative 14, and then the store button is right next to the 1. Okay, that STO arrow is store, and then the x button is right above that. And then press enter. That's how you store a value for a variable. Okay? Now I'm going to take the absolute value, so if you hit the math button and go to the right, that ABS is absolute value. Okay, so math, right, enter. And now I can type my negative 9 minus my x. It gives me 5, which my original equation is 5. So that's a good solution. That's one of my answers. Okay, so then I'm going to take the negative 4 and store that for x. So negative 4, store for x, enter. And then I'm going to make it easy on myself. I'm going to hit the up arrow until that original equation is highlighted, and I'm going to press enter. Now it's going to evaluate it when x is negative 4, which still gives me a 5, so both are good solutions. Okay? Questions on that? Okay. All right, number 4. The absolute value of 3y minus 15 equals 21 is already by itself, so I can split 3y minus 15 equals positive 21, and 3y minus 15 equals negative 21. And then how do I solve that? What's my first step? Add my 15. 3y is equal to 36. Divide by 3, and y equals 12. Okay, then I do 3y minus 15 equals negative 21. I'm going to add my 15 here. 3y equals negative 6. Divide by 3, and y equals negative 2. Okay, now we're going to do our calculator. We're going to take 12, store it for x, and then go to math, right, enter to get your absolute value bars. And it's going to be 3x minus 15. Gives me 21, which my original answer does say. I want this value to equal the right side of my equation. What I'm checking is, does my left equal right? Is it a true statement? Okay. So then I'm going to take -2, store it for x, go back up and grab the absolute value of 3x minus 15. Also gives me 21. So they are both good solutions. Okay? Questions on that? So on number 5, the absolute value bars are not by itself. Okay, so what do you think I need to get rid of first? The 3 or the 10? So if you're ever looking at it and you're not sure, okay, imagine if this were 3x plus 10 equals 37. If it were just a 3x and I was solving for x, what would I do first? Subtract my 10. I'm going to treat the absolute value bars like I would be solving for x. So you're always going to add or subtract first if it's set up like this, then divide. Okay, so I'm going to subtract my 10. 3 times 2x plus 5 in my absolute value bars equals 27. Then I'm going to divide by 3. And notice that I'm not changing anything inside my absolute value bars. Nothing inside the absolute value should be affected. Okay, we don't distribute the 3. We don't manipulate those numbers at all. So I'm still left with the absolute value of 2x plus 5 equals 9. Now I've got it by itself. I can split 2x plus 5 equals positive 9 and 2x plus 5 equals negative 9. Okay, now we solve. So I would subtract my 5. 2x equals 4. Divide by 2. And x equals 2. Then I'm going to subtract my 5 again. 2x equals negative 14. Divide by 2. And x equals negative 7. Okay, do we have questions on that? Okay. So then I take 2 and store it for x. Now I'm typing my entire original problem on the left. So I'm going to have my 3, then go get my absolute value bars. 2x plus 5. Get outside of those bars with your right arrow and then do your plus 10. And if it equals 37, which it does, that's a good solution. Then do the same thing with negative 7. Store it for x. Go back up and grab. Also gives me 37, so they're both good. We good with this? Okay. So then number 6, I have the absolute value of 6x plus 8 over 4 plus 12 equals 20. Okay, so this entire thing is together. So I want to get rid of this 12 by subtracting it. And I have the absolute value of 6x plus 8 divided by 4 is now equal to 8. Now, if the absolute value is being divided by 4, what am I going to do to undo that? I'm going to multiply by 4. So then the absolute value of 6x plus 8 equals 32. Now I want to do what next? I'm going to split it. 6x plus 8 equals positive 32, and 6x plus 8 equals negative 32. Alright, subtract my 8. 6x equals 24. Divide by 6, and x equals 4. Subtract my 8 again. 6x equals negative 40. Divide by 6. When you take negative 40 divided by 6, I'm just going to do this in the calculator again for you, so you get used to those buttons. I get a decimal. I don't want decimals. I want fractions. So second fraction, enter, gives me a mixed number. I don't want a mixed number. So I'm going to hit second and then what looks like a mixed number. And that will give me my negative 20 over 3. Okay. Now we're going to check it. Now, when I'm going to go ahead and store this negative 20 over 3 because it's already on my calculator. So if I hit just automatically store, it takes that answer that I just got, stores it for x. It puts it back as a mixed number, but that's okay because the calculator is just using a value. Okay, so I'm now just checking the right one. So I'm going to set up my fraction, and I'm going to get my absolute value bars. 6x plus 8 over 4 plus 12. Gives me 20. So negative 20 over 3 is a good value for x. So now I'm going to take 4, store for x, go up and grab my original, also gives me 20, so I'm good. Okay? Okay, now with number 7, I've got the absolute value of 2x plus 12 equals 4x. It's okay that I have an x over on the right. All I'm caring about right now is that my absolute value bars are by itself, which they are. Okay, so I can go ahead and split it. 2x plus 12 equals 4x, and 2x plus 12 equals negative 4x. Okay, now I want my x's on one side, my constants on the other. Okay, it would be easier if I just moved this 2x over to the 4x, so I'm going to subtract my 2x. So 12 equals 2x. Divide by 2, x equals 6. Okay, then I'm going to do the same thing, move that 2x over to the negative 4x, so I'm going to subtract 2x, and 12 is equal to negative 6x. Divide by negative 6, and x equals negative 2. Okay, so now that my right side has an x, I have to check both sides. Okay, so I'm going to take my 6 and store it for x. And then I'm going to do the absolute value of 2x plus 12 for my left side. That gives me 24. And then I'm going to check my right side. If I took 6 and plugged it in, I'm doing 4 times 6, which is also 24. So when you have an x on the right, you have to check both. You want to make sure left is equal to right, which that is, so x equals 6 is good. Okay, now I'm going to take my negative 2, store it for x. And if I plug that into the absolute value of 2x plus 12, I get 8. But if I take 4 and multiply it by negative 2 for my x on the right side, I get negative 8. Is that true? No. That is when you get your extraneous solution. When you plug it back in and the left side does not equal the right for your original equation. Okay, so when it is extraneous, you just mark through. Do not box it. Do not leave it blank. You mark through it. That's you telling me, hey, I understand this doesn't work, without me forcing you to write extraneous every single time. Okay? Do we understand that? All right. Okay, number 8. Absolute value of 8 minus 5x equals 4 plus 15x. Okay, now I have two terms on the right, which is okay. I still have nothing added or subtracted here, so I can split it. 8 minus 5x equals 4 plus 15x. And then 8 minus 5x equals, now I'm making the entire right side negative. Okay, so I'm doing negative with my 4 plus 15x in parentheses. I have to distribute the negative to all the terms on the right. Okay, so on that side I'm going to have 8 minus 5x equals negative 4 minus 15x. Okay, so when you make the right side negative, you're just changing the signs. Whatever the signs are, you just change them. Okay, now we can solve. I want my x's on one side and my constants on the other. Okay, I want you to work that out, get your answers, and check it, and then we're going to see if you got it right. Was what? I can't hear you. These two. So for this left equation, you should get x equals what? This one? The positive? So you should have gotten what, 1/5? Okay. And then the right side, you should have gotten x equals negative 6/5. Is that what y'all got? Okay. Do I need to work that out? Okay. So you could have added your 5x to the 15x and then subtracted your 4, or you could have subtracted your 15x, subtracted your 8. I want positive x's, but if you are always bringing your x to the left, then you would do it different. But either way, I would say subtract my 4 and add my 5x. And that's going to give me 4 equals 20x. Then I divide by my 20, which reduces to 1/5. Okay? If you would have had that in your calculator, 4 divided by 20, make that a fraction, it gives you a down arrow. Okay? Remember, the down arrow means you need to simplify. And there's my 1/5. Okay? And then for the other one, I would have added 15x just because I can see where my positive and negatives are. But if not, that's fine. You can do it the other way. I wasn't supposed to cross that out. That would have given me 10x equals negative 12. So then divide by 10, and that negative 12 over 10 simplifies to your negative 6 over 5. Okay? And then when you check it, did y'all get that far checking it? Okay, y'all check these two on your own, see if they both work. Okay, do they both work? No. 1/5 should work, but the negative 6/5 should have been extraneous. Okay? Are we good with this section? Because that's equations. We're about to move on to inequalities. Okay? No questions on those. Alright. When you do absolute value inequalities, we're going back to 1.1 with our and our or compound inequalities. Okay, so if you struggled with that, here's a little bit of extra practice, but this means that if you struggled, you need to start seeing me for help. Okay, so if I give you the absolute value of x needs to be less than 2. Okay, remember absolute value is the distance a number is from 0. So this is telling me the distance from x and 0 needs to be smaller than 2. If I only worked with positives, then that means, okay, as long as it was between 0 and 2, I'm good. That would be less than 2. Okay, the distance would be less than 2. But it's absolute value. So I have to also consider the negative. So if the distance needed to be less than 2 from 0, then that also considers, I could go all the way to negative 2 as well. Okay, so that means I've got from negative 2 to positive 2, and those in between could be less than 2. What does that look like? You should recognize that as an and inequality. Okay? Now, if I said the absolute value of x needed to be greater than 2, then that means that distance needs to be larger than 2. I need to either be greater than 2 in the positives or less than negative 2 in the negatives. Okay, so I've got anywhere going to the left of negative 2 and anywhere going to the right of positive 2. And that should look like an or inequality. Okay? So what happens is when you have, say, the absolute value of 2x plus 3 is less than 5. Okay, that means I need the distance from this 2x plus 3 expression in 0 to be less than 5. Okay, so if it's less than, I'm going to build an and inequality. And if you remember from 1.1, I gave y'all a template. It should always be a number is less than something in the middle, less than the other number. Okay? So the right side is going to look exactly like this. 2x plus 3 is less than 5. But I need the left side of it also. So I'm going to have another less than. And then when we were solving the equations, what did I always have? I had a positive and I had a negative. So I'm going to have a negative 5. Okay, so whatever is inside the absolute value bars gets dropped in the middle. It's always going to be less than on both sides. The positive is on the right, the negative is on the left. And then you solve. Okay? Now, if I had that same absolute value of 2x plus 3, but now is greater than 5, I want away from 0. I don't want it close to 0, I want it away from 0. So this is going to be my OR. Okay, so my right inequality is going to be the 2x plus 3 is greater than 5 because positives is always going to go on the right. But my left inequality, I'm going to have that 2x plus 3. When I make that 5 negative, I'm going to flip that inequality symbol. So it's now 2x plus 3 is less than negative 5. Okay, negatives always go on the left. You should know from your OR, your inequalities should always be pointing outward. They should never be inward. Okay? So this is going to be something you have to memorize. Alright, now this is the y behind why it's an and, why it's an or. Okay? Now I'm going to tell you how to use this trick to memorize. How is it going to be an and or an or when you're doing your stuff on your own? Okay? If you visualize the alphabet, A all the way to O. Okay, visualize that in front of your head. You start with A for and, go all the way to O for or. Okay? If I have less than, what direction is it pointing? To the A or the O? It's pointing to the A for and. So if it's less than, it's pointing to A for and. Okay? If it's greater than, it's pointing to the O for or. If you can visualize your alphabet. Okay? That's honestly what I use still to this day to keep them straight in my head. Okay? So whichever one it's pointing towards, that's the inequality you use. Okay? But if you don't know your inequalities and you don't know what an and versus an or looks like, we have bigger problems. Okay? So you got to make sure you have 1.1 down for you to be able to do 1.5. Okay? Now, Friday when I taught this, it was pep rally schedule and all the computer issues and all the things. We got interrupted a million times. So I actually did not teach graphing, set builder, or interval notation. I didn't get to it. Okay, so all we're doing is solving. So 1.5 just got super easy for you, as long as you know your inequalities. Okay, so on the quiz, y'all are not going to have to do set builder and interval. Okay, I'm going to tell you to scratch it off. On the test, same thing. We took it off. Okay, so on the worksheet, when you're checking the key, you're just going to have to look at my set builder inside of it, and that will be your inequality. Okay, so if I have absolute value of 6 minus 3x, minus 3 is less than 6, I still want these absolute value bars by itself. So I'm going to add my 3. I have the absolute value of 6 minus 3x is less than 9. I do not determine if it's an and or an or until those bars are by themselves. Okay? Now they are, so I'm going to look at my sign. It's the less than. Is that going to be an and or an or? An and. So when it's an and, I copy down that 6 minus 3x. I put my less than on both sides. Copy down my positive 9 on the right. What goes on the left? negative 9. And then I solve it. I want my 3x, negative 3x by itself in the middle. So I'm working inside out. Subtract your 6. So negative 9 minus 6 gives me negative 15, less than negative 3x, less than 9 minus 6 is 3. Then I'm going to divide by a negative 3. When I divide by a negative, what do I have to remember? I have to flip the inequality symbols. So they're now going to be greater than. Negative 15 divided by negative 3 is a positive 5. 3 divided by negative 3 is a negative 1. Okay? Now, if I know anything about my and, I know this is wrong. Why is this wrong? My negative is on the right and my signs are in the wrong direction. Okay, so I'm going to scoop it and flip. Okay, so everything flips over. So I've got negative 1 is now less than x less than 5. Okay, for you, that's your answer. For my answer key, that will be inside set builder notation. Okay. Do you understand how to solve that? Okay. Now, if I have the absolute value of g minus 5 is less than 15, I don't have to solve for that. So is it an and or an or? It's an and. So I'm going to drop my g minus 5, less than on both sides. Drop the 15. And what goes on the left? Negative 15. So then, I add my 5 to both sides. All three sides, actually. Negative 15 plus 5 is negative 10, less than g, less than 20. Is that what I need it to be? So that's my answer. You should all be capable of graphing and putting it in set builder and interval, but we just didn't have time. Okay, number 3, what would I do first? So the absolute value of 6x minus 7 is greater than or equal to 11. Now I decide, is it and or? It should be an or because it's pointing to the right. Okay, so that means I should have a left inequality or a right inequality, right? Okay, this 6x minus 7 is greater than or equal to 11. That positive is always going to be on the right. The left is going to be 6x minus 7. Flip your inequality symbol is less than or equal to the negative 11. And now I solve them. Remember, an or is solved separately. So I'm going to add my 7. 6x is less than or equal to negative 4. Divide by 6, and x is less than or equal to. Negative 4 over 6 is going to simplify to negative 2/3. And then I've got 6x minus 7 is greater than or equal to 11, so I'm going to add my 7. 6x is greater than or equal to 18. Divide by 6, and x is greater than or equal to, should be 3. Put your or in the middle. My smaller number is on the left. My inequalities are pointing outward, so that's what I need it to be. There's my answer. Okay, on number 4, I've got the absolute value of 4y minus 7 plus 8 is less than 17. I want you to try to do this one. Okay, you should have done what first? Subtract your 8, so you get the absolute value of 4y minus 7 is less than 9. And then you created what type of inequality? So you should have negative 9 is less than 4y minus 7 is less than positive 9. Did y'all get that? Set it up right? And then add your 7. So negative 2 is less than 4y less than 16. Divide by 4. You get negative 1/2 is less than y less than 4. Y'all good with that? Okay, on number 5, I have negative 4 times the absolute value of x minus 6 is greater than or equal to 12. So I should be dividing by negative 4. When I divide by that negative 4, what happens? I have to flip the sign. So it's now the absolute value of x minus 6 is less than or equal to 12 divided by negative 4 is a negative 3. Okay? Now, with equations, I said the moment you have a negative, you need to start thinking about positive and negative relationships. Okay? So the same thing with inequalities. I need to start thinking about what is this actually saying? I've got the absolute value, which we know absolute value is always what? Positive. So this is saying I have a positive value less than or equal to negative 3. Is that true? Can a positive, doesn't matter what it is, a positive can never be less than a negative. So it's no solution. There's no work to be done. So I would be checking if you isolated your absolute value bars, and then you should automatically go to no solution. Okay, so the moment you have a negative on the right, you need to think, is this true or not? Does this make sense? Okay. So number 6, I've got the absolute value of x plus 2 is over 4 plus 3 is greater than 5. So since the absolute value of x plus 2 over 4 is all one term, I'm going to subtract my 3. That's going to leave me with it being greater than 2. Now the absolute value is being divided by 4, so I'm going to multiply by 4. So the absolute value of x plus 2 is greater than 8. Is that an and or an or? It should be an or. So my left inequality is that x plus 2. I know I'm making it negative. Negative, I have to flip it, less than -8. Or x plus 2 is greater than my positive 8. Then I'm going to solve subtractor 2. X is less than -10. Subtractor 2. X is greater than 6. Those are the directions I need my inequalities. My smaller numbers on the left, so I'm good. Okay. Now we have one more example. I have -2 times the absolute value of x minus 4 is less than or equal to 10. What do I do? Divide by -2. When I divide by -2, it leaves me with the absolute value of x minus 4 is greater than or equal to -5. Now what does that make it? Okay, if it were positive 5, it would make it or. Not necessarily, right? I have a positive value for absolute value, right? And it's saying anything positive is greater than or equal to -5. Is that true? Is a positive greater than a negative? Yes. So this is all real numbers. So you have to be careful. Just because it's negative doesn't make it no solution. You have to understand the relativity of your positive and negative, and if it is greater than or less than. Okay? Do we understand the difference between that and the other one? Okay. So, you have a quiz over this next class. You're going to have some absolute value equations, some absolute value inequalities. Okay, so you've got the rest of the time to work on your worksheet. I'm going to go ahead and hand out your review in case you're absent Wednesday. You don't have to work on your review. Okay, it's just in case you're absent, you already have it. Okay?